For thousands of years, humanity has searched for answers. Google seems to have an answer. It has unveiled a new chip called
The universe has always whispered its secrets to those who dare to listen. For millennia, humanity has gazed at the stars, traced the arcs of comets, and pondered the unseen forces that stitch reality together. We've built temples to the gods, crafted equations to map the cosmos, and told stories to make sense of our place in it all. But what if the truth lies not in the heavens above or the atoms below, but in a hidden layer, a realm so strange, so elusive, that even our wildest dreams couldn't touch it? In the winter of 2025, a machine called Willow, born from the minds at Google, hummed to life in a frigid laboratory, its circuits colder than the void of space. This wasn't just another computer. It was a quantum marvel, a 105-qubit processor that didn't just crunch numbers, it danced with the very fabric of existence. And in its fleeting 5-minute performance, it may have peeled back a veil, revealing a glimpse of something deeper, something that could redefine what we believe is real. Picture a room, sterile and silent, save for the faint hum of machinery. Inside, a chip no larger than a coin sits at the heart of a labyrinth of wires and cooling systems, bathed in temperatures so low they make the Antarctic seem balmy. This is Willow, Google's quantum leap into the unknown. For years, scientists have chased the dream of quantum computing, a technology that doesn't just process information, but manipulates the bizarre rules of the quantum world. Where particles can be two things at once, where connections defy distance, where reality itself seems to bend. Willow isn't the first of its kind, but it's the first to sing a song so clear, so precise, that it's forced us to question whether we've been looking at the world through a fog lens all along. Its 105 qubits, those tiny superconducting circuits, aren't just tools for computation. They're keys to a door we didn't know existed. And what lies beyond might be more than we're ready to understand. To grasp the weight of Willow's achievement, you have to imagine the impossible. Think of a puzzle so vast, so intricate, that solving it would take a classical supercomputer longer than the universe has existed. 10 septillion years, a number so absurd it dwarfs the age of stars, the lifespan of galaxies, the slow decay of black holes. Willow solved this puzzle, a task called random circuit sampling, in under 5 minutes. 5 minutes. The time it takes to brew a cup of coffee or scroll through a feed on your phone. In that fleeting moment, Willow didn't just outperform every computer humanity has ever built. It hinted at a computational realm so alien, so vast that it feels like cheating the laws of nature. But this isn't a story about speed alone. It's about control, about taming the wild, fleeting nature of the quantum world to do our bidding. And that's where the real magic begins. The heart of Willow's triumph lies in a breakthrough that sounds almost mundane: error correction. Quantum computers are fragile creatures. Their qubits, those delicate quantum bits, are like dancers balancing on the edge of a knife. A whisper of heat, a stray electromagnetic wave, a vibration too soft to feel, and they collapse, their quantum magic dissolving into chaos. For decades, this fragility has been the Achilles heel of quantum computing. Every step forward was haunted by mistakes, like a symphony where the musicians kept missing notes. Google's engineers, though, found a way to rewrite the score. They wove Willow's 105 physical qubits into a pattern called a surface code, a kind of quantum tapestry where information isn't held in one place, but spread across many, like a secret whispered among friends. If one qubit falters, the others hold the truth, correcting the error without breaking the spell. This wasn't just a technical fix, it was a revolution. For the first time, a quantum computer didn't just perform, it performed reliably, its results as trustworthy as they were astonishing. Imagine building a house with bricks that crumble under their own weight. The more bricks you add, the faster it falls. That's been the story of quantum computing until now. More qubits meant more errors, more chaos. But Google flipped the script. With Willow, they discovered that by arranging those crumbling bricks in just the right way, the house doesn't just stand, it grows stronger. The more qubits they added, the more stable the system became. This is the power of the surface code, a pattern that turns fragility into strength. It's as if they found a way to make the wind hold up a sail instead of tearing it apart. This breakthrough doesn't just make Willow faster, it makes it possible to dream of quantum computers that can scale, that can grow, that can tackle problems we've never dared to imagine solving. Problems like designing new medicines, unlocking the secrets of materials, or even modeling the chaotic dance of molecules in a way that could save our planet from its own excesses. But what does it feel like to stand on the edge of such a discovery? For the engineers who built Willow, it must have been like holding a star in their hands. Beautiful, volatile, almost impossible to comprehend. The chip itself is a marvel of human ingenuity, a tiny square of silicon and superconducting metals, cooled to 10 millikelvin, a temperature so cold it's closer to absolute zero than anything in the natural universe. Inside its dilution refrigerator, a machine that costs millions and uses rare helium isotopes to create this unearthly chill, Willow's qubits perform their quantum ballet. Each qubit is a circuit, a whisper of aluminum and niobium, engineered with a precision that makes the finest watchmaker's craft look clumsy. These circuits don't just carry information, they exist in a superposition, a state where they're both 1 and 0, yes and no, here and nowhere, all at once. To control them, Google's team sends microwave pulses timed to trillionths of a second. Each pulse a note in a symphony so delicate that a single wrong beat could unravel the entire performance. The challenges were staggering. Every qubit needed multiple control lines, a tangle of wires that had to remain pristine through layers of freezing cold. The team battled crosstalk, where qubits accidentally nudged their neighbors, creating errors like ripples in a pond. They wrestled with the software, translating abstract quantum algorithms into the physical language of pulses and circuits. And they did it all in an environment where the slightest interference, heat, vibration, a stray photon, could shatter the quantum state. It's like conducting an orchestra in a storm, with every instrument strung with gossamer threads, and somehow Google made it work. They didn't just build a machine, they built a bridge between our world and the quantum one, a bridge that might lead us to truths we've only glimpsed in dreams. And yet, for all its technical wizardry, Willow's story isn't just about circuits and code. It's about what it means to be human, to reach for the unknown, to chase a question even when the answer might unsettle us. When Willow completed its task in those 5 minutes, it didn't just break a computational barrier, it sparked a firestorm of wonder. Some whispered of parallel universes, of hidden realities where every possibility plays out. Others saw it as proof that we're finally mastering the quantum world, bending its rules to our will. The truth, as always, lies somewhere in the tension between these ideas. Willow didn't open a portal to another dimension, but it did something just as profound. It showed us that the boundaries of what's possible are far less fixed than we thought. And as we stand on this precipice, peering into the quantum unknown, we can't help but wonder, what else is out there, waiting to be discovered? The air in the lab is thick with anticipation, a quiet hum of machinery underscoring the moment. Willow, Google's quantum marvel, has just done the unthinkable, solving a puzzle in 5 minutes that would take a classical supercomputer 10 septillion years. But the real story isn't just the speed, it's what Willow's dance with the quantum world suggests about reality itself. As its 105 qubits flickered in their frigid cocoon, they didn't just compute, they whispered of a universe stranger than we'd ever imagine. The question now isn't just what Willow can do, but what it means for us, for our future, for the very nature of existence. Are we standing on the edge of a new era, or have we stumbled upon a truth too vast to grasp? This isn't about numbers or circuits alone. It's about the human heart reaching for the unknown, chasing a spark that could light up the world or burn away our certainties. Willow's breakthrough, the surface code that tamed its fragile qubits, is more than an engineering feat. It's a promise that quantum computers can grow, not just in power, but in trust, becoming tools we can rely on to unravel mysteries we've only dared to dream of. Imagine a world where we design materials that defy physics as we know it, superconductors that carry electricity without loss, powering cities with a fraction of the energy we use today. Picture batteries that charge in seconds, electric cars that roam for thousands of miles, or solar panels that drink sunlight with near-perfect efficiency. These aren't fantasies. They're possibilities Willow brings closer. Its error-corrected qubits a key to unlocking the quantum secrets of matter itself. But the road to Willow was no easy path. It was a journey through a wilderness of challenges where every step forward risked a fall. The qubits, those tiny circuits of aluminum and niobium, live in a world so delicate that a single stray photon could shatter their quantum state. Google's engineers had to shield them from everything: heat, vibrations, even the faint buzz of the world's electromagnetic noise. They built dilution refrigerators, million-dollar machines that plunged temperatures to 10 millikelvin, colder than the darkest corners of space. They wove a web of control lines, each one carrying microwave pulses timed to trillionths of a second, a precision so fine it feels like threading a needle in a hurricane. And then there was the crosstalk, the ghostly whispers between qubits that could turn calculations into chaos. Solving this meant calibrating each qubit to sing in harmony with its neighbors, a symphony where one wrong note could ruin the whole. Yet for all its complexity, Willow's story is deeply human. It's about the people who poured their minds and hearts into this machine: physicists, engineers, coders, dreamers. They weren't just building a computer. They were wrestling with the universe itself, asking questions that echo back to the first humans who looked at the stars and wondered why. What makes Willow extraordinary isn't just its power, but the audacity of its creation. It's a testament to what happens when we refuse to accept the impossible, when we push past the limits of what we know to touch something new. And in that touch, Willow has sparked a firestorm of questions. Did it glimpse a hidden layer of reality? Did its qubits, dancing in superposition, tap into something beyond our equations? The headlines screamed of parallel universes, of other worlds where every choice plays out. But the truth, as always, is both simpler and stranger. Scientists are quick to ground us. Ethan Siegel, an astrophysicist with a knack for cutting through the hype, is blunt. Willow's feats don't prove multiverse theories. They don't need to. What Willow did, executing random circuit sampling with such precision, fits perfectly within the rules of quantum mechanics we've known for a century. No hidden realities, no secret dimensions, just a machine that harnesses the weirdness of quantum behavior better than anything before it. Sabine Hossenfelder, another voice of clarity, calls the task a benchmark, a test designed to show quantum computers can outpace their classical cousins in ways that defy comprehension. It's not a portal to another world, but a mirror reflecting how much we've learned to control the one we're in. Yet even as they dismiss the wilder claims, scientists can't hide their excitement. Willow's error correction, that delicate dance of qubits woven into a surface code, is a turning point. It's the moment quantum computing stops being a fragile experiment and starts becoming a tool we can wield. This tool, though, isn't just for solving math problems or breaking records. It's a window into the universe's deepest mysteries. While Willow itself didn't probe parallel worlds, other quantum experiments are nudging us closer to the edges of reality. In 2022, researchers at Caltech used Google's earlier quantum processor, Sycamore, to simulate a quantum wormhole, a fleeting mathematical echo of a tunnel through space-time. It wasn't a real wormhole, but a model, a way to test theories about quantum gravity, the holy grail that might unite Einstein's relativity with the quantum world. These experiments are like peeking through a keyhole into a room we've never entered, where the rules of space, time, and matter bend in ways that feel like science fiction. They hint at a universe that might be a hologram, a projection from a lower dimensional surface, a concept so wild it makes your head spin. Willow, with its newfound reliability, could open that keyhole wider, letting us glimpse more of the cosmic puzzle. And then there's the human side of this revolution. Beyond the labs and equations, Willow's breakthroughs could touch lives in ways we're only beginning to imagine. In medicine, quantum computers could simulate molecules with such precision that drug discovery becomes a matter of years, not decades. Imagine treatments tailored to your DNA, or cures for diseases we've long thought unbeatable. The COVID-19 pandemic showed us how desperate we are for speed in a crisis. Willow's descendants could make future pandemics a footnote, not a catastrophe. In energy, quantum simulations could unlock carbon capture that actually works, pulling greenhouse gases from the air to slow the planet's fever. They could design materials so light and strong they transform how we build planes, bridges, or even cities. And in cryptography, Willow's power casts a shadow. Its ability to crack codes could upend digital security, but it's also spurring a race to build quantum-resistant systems, ensuring our secrets stay safe. But perhaps the most thrilling part is what we can't yet see. When the first computers hummed to life, no one predicted the internet, smartphones, or social media. Willow's success, its ability to tame quantum chaos, suggests a future where quantum computing reshapes our world in ways we can't imagine. It's not just about faster calculations. It's about new kinds of thinking, new ways of solving problems we didn't even know we had. As Willow's qubits danced their 5-minute miracle, they didn't just solve a puzzle, they lit a spark that could ignite industries, rewrite economies, or even shift how we see ourselves in the grand tapestry of the cosmos. And yet, for all its promise, Willow leaves us with a question that lingers like a melody you can't forget. If we've come this far, what else is waiting just beyond our reach? The hum of Willow's circuits has faded, but its echo lingers, a ripple across the fabric of our understanding. In a frozen lab, Google's 105-qubit quantum marvel didn't just solve a puzzle, it rewrote what we believe is possible. 5 minutes to conquer a task that would take a classical supercomputer 10 septillion years. A surface code that turned fragile qubits into a fortress of reliability. This wasn't just a machine, it was a glimpse into a future where the quantum world bends to our will, where the mysteries of reality might finally yield their secrets. But as we stand in the glow of Willow's triumph, we're left with a question that tugs at the soul. What does it mean to touch the edge of the unknown, to hold a key to a door we can't yet see? Willow's story is a bridge between the tangible and the ethereal. Its error correction, that delicate weave of qubits, isn't just a technical feat, it's a spark that could ignite a revolution. Picture a world where quantum computers design drugs that save millions, tailored to the unique rhythm of your body. Imagine climate models so precise they predict storms weeks in advance, saving lives before the winds even stir. Envision AI that learns not in months but in hours, untangling patterns in data too vast for human minds. These aren't dreams. They're doors Willow has cracked open. Its surface code, spreading quantum information like a constellation of stars, shows us that quantum machines can scale, can endure, can become tools as reliable as the smartphones in our pockets. And in that reliability lies the power to reshape our world. Yet the path to this future is a labyrinth. Building Willow was like sculpting with mist. Its qubits, those slivers of superconducting metal, live in a realm so fragile that a single errant vibration could unravel them. Google's engineers battled this chaos with a precision that borders on the miraculous. They crafted dilution refrigerators, chilling the chip to 10 millikelvin, a cold so deep it humbles the void of space. They tamed crosstalk, ensuring each qubit's whisper didn't disturb its neighbors. They wrote software to translate the abstract language of quantum algorithms into pulses of microwave light, each time to trillionths of a second. Every challenge was a puzzle, every solution a small victory in a war against the unpredictable. Willow's existence is a monument to human tenacity, a proof that we can wrestle with the universe's strangest rules and emerge with something real. But Willow's true power lies in what it asks us to imagine. Beyond the practical, new materials, faster drugs, stronger encryption, lies a deeper quest. Quantum computers like Willow are becoming telescopes into the nature of reality itself. Experiments across the globe are using these machines to probe questions that sound like poetry. At the University of Vienna, researchers have toyed with quantum entanglement, sending information in ways that seem to defy time's arrow. In China, satellites have stretched quantum links over 1,000 kilometers, testing the limits of connection across vast distances. At Caltech, scientists used Google's earlier quantum chip to simulate a wormhole, a mathematical shadow of a tunnel through spacetime. These aren't just experiments. They're conversations with the cosmos, asking whether our universe is a hologram, whether gravity and quantum mechanics can ever sing in harmony, whether reality is more fluid than we dare believe. And yet, for all its grandeur, Willow's story is grounded in humility. The headlines that screamed of parallel universes were met with a scientist's shrug. No multiverse here, they said, just quantum mechanics doing what it's always done, only better. Ethan Siegel and Sabine Hassenfelder, voices of reason in the storm, remind us that Willow's feats align with theories we've known for decades. No hidden layers of reality, no secret dimensions. Just a machine that dances with superposition and entanglement so deftly it outpaces anything classical computers can dream of. But this clarity doesn't diminish the wonder. If anything, it sharpens it. Willow shows us that the rules we already know are strange enough to change everything, that mastering them could unlock futures we can't yet name. What makes Willow's tale so gripping is its humanity. It's not just about qubits or algorithms. It's about us, the engineers who built it, the dreamers who dared to ask, what if? The countless hands that turned a wild idea into a machine that hums with possibility. They remind us that every leap forward begins with a question, a spark of curiosity that refuses to fade. Willow is a testament to that spark, a beacon of what happens when we chase the impossible. It's the Wright brothers' first flight, the Apollo mission's moonlit steps, the internet's first tentative connections. Each was a moment when the world shifted, when what seemed out of reach became real. Willow is that moment for quantum computing, a proof that we can harness the universe's weirdest rules to build something new. As we step back from Willow's glow, we're left with a feeling that's hard to name. Awe, perhaps, at how far we've come. Hope for the worlds we might build, and a quiet unease, because every discovery reshapes not just our tools, but our sense of self. Willow didn't pierce a hidden layer of reality, but it showed us how much we still don't know. Why do quantum effects vanish in our everyday world? What happens when we scale these machines even further? When we push past 105 qubits to thousands, millions? Will we find answers that comfort us, or ones that unravel our certainties? These questions aren't just for scientists. They're for all of us, because the future Willow heralds belongs to everyone. In the end, Willow's story isn't about a single machine or a single moment. It's about the human spirit, forever reaching, forever questioning. It's about a species that looks at the stars and builds tools to touch them, that peers into the quantum haze and finds not just answers, but new mysteries. Willow has shown us a path forward, a way to make the quantum world not just a curiosity, but a partner in our journey. And as we walk that path, we carry a truth as old as our first fires. The unknown isn't something to fear, but something to embrace. Because in its shadows, in its whispers, we find not just the secrets of the universe, but the courage to keep asking who we are and who we might become.